Hi, this is Pablo, and today we're going to start with a new also series of videos talking about um, joints. Okay, connection joints. They're going to connect parts together for a machine design. Okay, I'm going to probably make several kind of like groups of elements talking about different topics about how to design machines, okay, for automation. Okay, we're doing the first group of tutorials to basically more for automation with this software factory IO and then PLC, but also I'm gonna make another type of videos more mechanical, talking about different things from materials, material mechanics, pneumatic systems, hydraulic systems, stresses, mm, thermodynamics, and also design engineering. Okay, including not just how to design parts using CAD softwares, but also these kind of things like connections, how to connect parts, how to make assemblies, and so on. Okay. In this part, we're going to start with the joints. Okay, joints are pretty much the elements that they are needed to connect different parts together to conform a mechanism or an assembly. Um, Typically, except for like few new processes, you have to make assemblies and mechanisms in like connecting a lot of parts together, okay, because you can manufacture everything in one. Okay, there's some 3D printing things that they're starting right now, but still so far, to design a machine, okay, or for like building constructions or a plane or a car, typically you need um, a lot of parts together. Okay, and how do you connect those parts? Well, you go with different type of connections, and typically not always, but they are one of the weakest parts of the assembly. Okay, and you have to spend a little bit of time to see that everything is strong enough and it's going to resist all the stresses that you need. So between all these parts, we're going to talk about in the connections. We're going to talk about bolt connections, screws. We're going to talk about pins or double pins. We're going to talk about adhesives or glues, a weld. Okay, welding is one of the most important ones, and also maybe rivets and nails, things like that. Okay, you can connect wooden parts too. But today we're going to start with the bolts. Okay, the bolts is going to require also a few group of videos because there is a lot of topic to talk about bolts. Okay, it doesn't seem, but it is. Okay, it is very important, and there is a lot of parts to talk about. Okay, so first we're going to talk about the introduction, which is going to be this video. Then we'll make another video talking about non-preload bolts. Then we will talk about a chart that I made, try to help um, to find out stresses and what type of bolt you can use, both for size and also for material. And then we'll start with the preload bolts. Okay, what is preload and why do they preload the bolts? And then we'll probably continue with different type of specific examples for forces that they are eccentrical, both in the same plane or out of plane, and then maybe things more. Okay, little by little, I'm trying to put everything in a specific website I'm creating. Okay, this is for example for the bolt group, which is that eccentrical wing thing with the charts, so you can download everything. Okay, and you can have it in text or in Excel to play with and understand what I'm saying. Okay, so far the only one that I activated is introduction. Okay, and then we'll go one by one. The same with the screws, pins, welding joints, and then so on. Okay, so we're going to talk about today introduction. Okay, and we'll explain what is a bolt joint, elements needed in a bolt group. Okay, and differences between a bolt and a screw. Okay, and then we'll talk about the standards, different type of standards, and then we'll see maybe some links that I use to create this file. So what is a bolt? Okay, a bolt connection. Sorry, what is a bolt connection? A bolt connection is one of the most famous and one of the first ones you're gonna think about when you have to connect two parts together. Okay, typically you're gonna think about welding. You're gonna think about uh, putting some adhesives, maybe rivets, or bolts. Okay, bolts is going to be one of the main ones you're going to think about, and typically everybody has seen some. Okay, a bolt is basically a bolt joint. Sorry, is basically this. Okay, the difference with other type of joints is a bolt joint requires some elements, not only one. Okay, what are those elements? Well, these ones are going to be the bolt. These elements are called within a bolt group. Okay, and they are the bolt, which is this one, the nut, and then washers. Okay, this is mainly always the same. Okay, that you can see in the different bolt joints. Okay, so basically these are here. A bolt is going to be similar to a screw. Okay, and it's a type of fastener, a metal fastener with external threads. Okay, and it is the main thing for the gold bolt group. Okay, it's this one. Then you're gonna get the nut, which is gonna have a internal thread. It's gonna be a female hardware fastener with an internal thread, which is gonna be threaded into the bolt. And then you're gonna get the washers. The washers, they are not 100% required in all the bolt groups. Okay, so you can see, for example, here is one that only has one, or maybe, for example, that one has a specific type of head that includes the washer. So it's not always required. However, in some of the connections, specifically the preloading ones, they are required. And also, it is always recommended to put a washer. Okay. The reasons why to put a washer is because it helps to prevent damaging the clamped parts, and also it secures better. Okay, it works really well, reducing the sleep of the group. Okay, especially for shear type of loadings. So summarizing, bolt, okay, it's gonna be similar to a screw. It's gonna have some differences. We're gonna talk. You're gonna find different types, and basically, typically, it is based on some standards. Okay, ISO is the main one for the metric, and then you get it in USA, ASTMs, and ASME, which I didn't write there. Okay. So what is the difference between a bolt and a screw? Okay. Well, it's not the same thing. Okay. Many people think that a bolt is, or a screw is, the typical like threaded fastener that you use for the wooden parts. Okay. Like for example, this type. Okay, for wood. Okay, or this type. And then a bolt is anything else, you know. For example, that considered a bolt. No, it's not true. Okay, the difference between a bolt and a screw is that the bolt is required for a bolt group, so it requires to have a nut. Okay, while the screw doesn't. Okay, so the bolt has a specific method to be connected. Okay, which is fixing the head with a wrench, for example, if you need, and then another wrench tightening the nut. While the screw, you have to tie it from the head, because the screw doesn't is not designed to use a nut. It's designed to be tightened to a tap hole. Okay, when it's a tap hole is a threaded hole that you make in a part. Okay, so the screw threads directly to the part, to the clamped part, while the bolt uses a nut. And we're going to see that in this English book. Yeah, you're going to see that better. We're going to see the two examples. Okay, fatigue. We're going to see. Oops, I think I went so far. Here it is. Okay, these are screws. For example, here, this is a bolt, this is a screw. Okay, the screw is being tightened to this part, which is going to have a hole that is threaded, while the bolt is going to be connected to a nut. Okay, it's going to be clamping two parts together. Okay, this is the main difference. So typically you're going to see, well, okay, I get it. These types are going to be screws, okay, because the way they are. In fact, they are called cap screw. In this case, socket head cap screw. And the other ones, well, typically they're going to be different. For example, you're going to get some designs that is going to have like a mushroom head bolt, for example, this type, okay, which is a little bit different, the head. However, there are going to be some types that they're going to be very similar, okay. So this is a bolt, as we can see, okay. This is a type of bolt, you can see, and this is a screw. Hexagon head cap screw. They're gonna be pretty much the same thing. Here it is. So this is a screw, this is a screw, and this is a bolt, and you're gonna see, but this is the same thing. Not exactly, okay? And now it gets confusing. The bolts, they have their own standards, and the screws, they have their own standards, okay? Yeah, why? Because the screws is designed to be tightening through the head. The bolt is designed to be fixing the head and tightening the nut, okay? That small difference is going to require, in some cases, different dimensions, okay? Specifically for the head. And also because commonly they use different types of standards for the materials, okay? And the properties, okay? And we're going to talk about this. We're going to separate that into the different types of standards, okay? But for example, a bolt is gonna have an ASTM in USA, an ASTM standard for the properties, and a screw is gonna be towards more an SAE, for example, type of the standards, okay? There are gonna be some grades and some classes for both. They're gonna be very similar, and the same thing with the dimensional one, but they're gonna have some differences, okay? So for example, a bolt is gonna use an ASME type of standard for the dimensions, and the screw another one, okay? Sometimes the screws, like this one, they're also called bolts, okay? And that makes everything more confusing. And the straight bolt, they are called structural bolts, okay? For example, this is a head screw, these are bolts, and you don't see hexagon type of head, which is the most famous type of bolt. But when you go here, you're gonna see, for example, extra wide head for high pressure applications with an ASTM. These, which is in fact going to be, I want to see here, let me see if I can find one better. Here, you're gonna get regular one, and you're gonna get high strength ones, medium, whatever. You're gonna see they're gonna start having a, I'm gonna go with the inch one. In this case, you're gonna get a specific type of a standard, okay, with an SAE, okay. This is a screw, okay. And if you see standards like an ASTM, or for example, let me see, this one, okay. So the screw is going to have what I so-called the screw is going to have this dimensional standard 18.2.1 for the dimensions, and SAE J429. This is in the imperial system, okay, not in metric. We'll talk about metric later, okay. That is going to be a screw. However, this, oops, sorry, no, this not here, this type, which is 2.6 with a structural bolts with this type of standards ASTM for the properties, that is going to be a bolt, okay. Well, it's going to be stronger, it's going to have a bigger head, okay, and it's going to be designed to resist high stresses, okay. That is going to be a bolt, two parts together, with resisting more stresses than in the case of the screws, okay? So I know everything is very confusing. What is my recommendation? My recommendation would be, first, use, here I explain the differences, use different type of standards, okay, to help yourself. If you're going to use bolts, use hexagon ones, for example, or other types. If you're going to use screws, use these types, for example, socket, rather than use this hexagon. However, there are going to be some cases that the hexagon works better. For example, if you want to preload the screw. In this case, try to differentiate the standards and use SAE's SME 2.141 and use 2.6 for the other one. Okay, in the case of the metric, there's going to be differences there, and we're going to see that, for example, these, we're going to talk about the standards later. These standards, they're specifically for screws, and you're going to get standards for, no, sorry, these are for bolts. You're going to get specific standards for screws, okay? And that is the way you're going to differentiate one or the other one. Here we're going to talk specifically for bolts, so we're going to put the standards for specifically for bolts, and in the screws we're going to put the standards for screws. So use one for one, the other for the other one. Try to be rigid with that, separate the things, and then that is going to help you a little bit. If you have to use the same thing, you can use a bolt as a screw, but if you can avoid, don't use a screw as a bolt, okay? Because being the head different, you can have some problems, okay? You can have some problems, specifically for big frame constructions. You can have some problems if everything breaks and they are calling for a bolt, you're putting a screw. So be careful with that, separating different specific standards. You can use a bolt as a screw, but don't use a screw as a bolt, okay? If you understand what I mean. So we're going to talk about the standards for the bolts. It's important to say, any fastener has up to 3 standards, okay? You should know them and you should use them, okay? The first of the standards is going to be the dimensional standard. That is going to tell you exactly what the standards are, and it's going to tell you exactly the tolerances, is going to tell you exactly the pitch, it's going to tell you exactly the how many like fillets you get, the design of the head, everything, okay? And then you're going to get the other 2 standards, okay? And these standards is going to tell you the type of bolt that you're going to find, and there are different groups. The first one is going to be the most typical one. There are probably much more, okay? These are the typical ones that I use, okay? Well, in fact, I only use the first one, and maybe a couple times I use the second one, but I never really use other types, okay? I'm pretty sure with more construction engineers, they're going to use all kind of bolts, okay? So check, because probably there's some websites you can find exactly all the types. If not, go to the standards. The hexagonal or hexagon head bolt, which is the regular one, works fine. It's like this type hexagonal one. You need 2 wrenches, one to fix the head, one to tie the nut, okay? And it's very similar to this type of a screw that we were talking, okay? But remember, different standards. Then you're gonna get the mushroom head bolt, which is going to be this type. No, this one, okay? It's gonna be, you can see that, for example, I've seen this a lot in bridges, okay, and this type of constructions, steel constructions. It has a specific rectangular section head, okay, to help the bolts to be tightened, okay. So basically, you don't need a wrench here. You only need the wrench to tighten the nut, okay. This forces you to tighten the correct way, because you cannot tighten through the head. You can only tighten through the nut, okay? This makes you tighten in the exactly correct way that a bolt should be tightened to. Okay, and then you get different ones. Flat washer bolt is going to be very similar to this. Maybe I can find some. Here you can find in McMaster, you got different options. You're going to have flat washer, so it's going to be like a conical flat one to flash with the clamp part, and then with the same square neck, okay, for tightening. The same thing, you can only tighten through the nut, okay. And then you get other ones, which is a pure let me see, square completely bold. I haven't seen those, but I'm pretty sure it exists. So well, here it is. Then we're going to start with the standards, okay? As you said, there are three types of standards. Dimensional standards, you get material standards, and then you're going to get coding standards. So as I said, standards are really important. Use them, okay? Use them because that defines exactly what board are you using. So if you get bolts here, for example, you're going to see that, especially if you want them to do a specific task, they're going to have different standards, okay? Sometimes you won't see the standards, okay? That is important to see, like, oh, if you want them, for example, to use them for a structural thing, do not use a bolt that doesn't have standards, okay? Do not, because then you don't know the material that it has, you don't know the properties, the alloy, if it's a steel, you don't know the dimensions, you don't know if it's a screw, if it's a bolt. So use them knowing the standards. That, for example, is a screw, okay? So we're going to see, let's say that one, no, it's also a screw, maybe in the screw area. This, for example, is not easy. This one I'm pretty sure is a bolt, at least has, here it is, for example. This one is a bolt and has the specific standard for dimensions and then material, okay? So we're going to start with the dimensional standards. I'm going to start with the metric, okay, which is the one that I use the most. And then we're talking a little bit about the imperial. I use it less, but well, if you work with any USA company or you are in USA, it may happen you have to use those. So in the metric, I'm going to specifically talk about the ISO ones, okay? And these are the typical ones that I've seen, okay? These are the standards. There are probably much more, but these are the main ones. You're going to get ISO 4014, which is the regular bolt, grade A and B, that is for the tolerance. You're going to get the 4015, okay, that one is with a reduced sank, is equivalent to the pitch diameter of the thread. Sank is the unthreaded part of the bolt. You're going to get the 16, which is going to be similar, just with grade C, tolerance for the thread. Then you're going to get the 17, which is the fully threaded, 4162 with the flange, okay, the flange is that, so you don't require a nut. For some areas where you don't want to use, a washer, you don't want to use a washer, okay, because it could fall into a turbine or something. And then you're going to get these other types, okay. This one is an hexagon regular head bolt with a fine thread, the mushroom bolt, and then, for example, a specific structural bolt for high structural bolting. And these I haven't used, so I can't really talk too much about them, okay? But these ones are regular ones. Check if you want. You can find probably in internet the ISOs. Some they're going to be free, some you have to pay. But here has all the pitch, all the dimensions for the thread, for the head, and everything. It is really fully dimensioned, okay? And then you get the nuts. Nuts, there's a lot of types. These are the main one. Regular hexagon nut, you get the class C for more tolerance, and then you get low profile, high voltage with the nylon insert, so locking nut and so on. And then you're gonna get some metrics that they are not gonna be the ISO, like DIN and ASMEs, which pretty much is gonna be the same thing, okay? In this case, the most used one for USA is the B18.2.6M, which is the so-called heavy hexagon bolt. I call that hexagon bolt. And then also for the nuts is inside of the standard. Pretty much that is gonna cover this ISO and the 4014 ISO, or maybe a few of them that I don't know, haven't seen this. When I use metric, I normally use ISO. And then the imperial for bolts, use the B18.2.6, okay, for structural bolts, and then the nut is gonna be the 2.2, okay. So this is the main first dimensional standard. When you're going to put in the part numbers, okay, in a BOM, in the part number you put bolt, and you can put ISO 4014. And then right away, you know exactly what type of bolt they're using, okay? Then you get the second type of standard, which is going to be the material or property standard, okay? This one is going to tell you what material is going to be, what is going to be the tensile strength, what is going to be the yield strength, the proof strength if you have a density, exactly the composition of the alloy, and all these things related to, okay? For the ISO, the main one is going to be the 898-1. Okay, this is going to be for steels and alloy steels. Okay, these are the main type of bolts you're going to use for structural parts. Okay, for constructions, machine frames, and so on. Okay, then you're going to get the 898-2 for steel nuts and alloy steel nuts. And then you're going to get for stainless steel the 3506-1, 3506-2 stainless steel nuts. And then you get non-ferrous material bolts 8839, which is going to be for both bolts, screws, studs, and nuts too. Okay, this standard is going to cover copper alloy bolts. It's gonna cover, and screws is gonna cover aluminum and titanium types. Okay, and then you get the equivalent of the ISO for metric in the USA. You're gonna get these types of ASTMs for stainless and for both nuts and fasteners for the non-ferrous ones. Okay, and then for the Imperial, I put here a link, by the way. You can go into Fastenal. They have a good amount of they have a good document explain all these. For the Imperial ones, you're gonna get these different ones for low carbon steel, medium carbon steel. As we see, like external bolts, typically they start with a big one, especially for the structural ones. Okay, that is a medium carbon steel, quenched and tempered, and you're gonna get probably different types. Each one of them is gonna have its own tensile, yield, proof stress. Okay, and you're gonna have to define that when you calculate the stresses that the bolt or the load that the bolt is gonna suffer. Okay. Stainless steel, you get high temperature. That is a really interesting one, by the way. Really interesting one. And then you get the non-ferrous ones, okay? And then the nuts. You're gonna get low carbon steel, maybe quenched and tempered. Medium carbon steel, typically quenched and tempered. You're gonna get stainless steels, and then you're gonna get the non-ferrous. Okay, so that is really important. And we're gonna see, for example, one of these standards so you can see what I'm talking about. I think I have it. If not, I will have to check it on the internet. Maybe I don't. No, I don't here. So we're gonna try to find an ISO 898-1. Here you can find in ISO, but you can find it maybe here, maybe using a PDF. Awesome. No. Well, this is not perfectly, but at least gives you an option. Okay, there are other types of classes. There are more. In fact, there are all these type of classes for the 898-1, 4.6, 4.8, 5.6, 5.8, 6.8, whatever. You're gonna get the tensile strength, minimum proof strength, and then you're gonna get sometimes the yield too. In this case, megapascals. The size range and the type of material is gonna be low carbon steel, medium, quenching, alloy steel, and all these, the hardness too, and all these is gonna be marked as a grade. Okay, for the ISO, you're gonna get a 4.6. And here is none of them. Here, all of them. 4.6, 4.0. This is only the proof tensile steel stress. You're gonna see these are the types. Okay, in megapascals. Okay, and that is based on the standard. Okay, you get the 3501. Okay, this one is gonna have soft, cold work, austenitics. You're gonna have martensitics, and then you're gonna have ferritic ones. Okay, and then you're gonna get that is the stress. It's the same thing. Okay, typically stainless steel are gonna be softer, typically, and they're gonna be a little bit less strong than these ones, but not always. Okay, they're gonna be a lot of really strong ones, and it depends on the case. We'll use either one or the other one, and then you get the other one, the copper alloys for the 8839, aluminum alloys, and then titaniums. Okay, the same thing. Some of the aluminums, for example, they're going to be weaker, but at the same time, some they're really strong. The same thing with the coppers. For example, this one is quite strong, and the titaniums you can see that is strong. Okay, just that it's probably expensive. Okay. Uh, so this is gonna be the main ones. Okay, the same thing for the imperial ones. You can find them really easily. And then we get with the third. One of the things important I have to say is that I'm talking about pretty much. I'm showing the strength of the bolts and not the nuts. The reason is because standard forces you to use a nut that is always as strong or stronger than the nut, than the bolt. Sorry. Okay. So when you find this one, you're gonna find this is per DIN, you can find the isotypes. The 8 class is always gonna be stronger than the 8 class for the bolt. Okay. So use the same type of class. You get a 10.9 class bolt, use the same type of nut. Okay, and the nut is gonna be always stronger than the bolt. So because the bolt is the most limiting part of the bolt group, we always reference the bolt when we calculate the stresses, okay? Because the nut is always gonna resist more, okay? The other interesting thing is that in tension, you have to say, which we will talk later, typically the first thing that is gonna break is gonna be the threads, okay? So we always use this type of stress area in the threads because it is designed that first breaking the threads rather than breaking in the head or in the sunk area, okay? So we're going to use always the threads, and the stress area is going to be in the threads, okay? This is what we're going to talk about. And then you get the third standard. The third standard is the coating, okay? These two are necessary when you're going to, the first two standards we were talking about, they are important, they're really important when you're going to use structural bolts. When I say structural bolts, it's bolts that you have to uh, resist some kind of stress, okay? When a bolts, they're going to be subject to stress, use two standards, this one and this one, okay? If they're more like decorative, for putting like a small panel there, like a plastic panel, things like that, then you don't have to. And there will be another standard for those. You don't even get the numbers. But when you really have to resist stresses, okay, which could be only for like 50, 200 kilos more tons, you have to use two standards and use them, okay? Then you get the third one. The third one is not mandatory, but it's present in many bolts, okay? And this is the coating, okay? The reason is because, especially for the steel ones, well, the steel is not really good against corrosion environments or oxidation. So you can coating, okay? These are some examples, okay? This is for electrodeposit coating for zinc, for example, for the alloy steel bolts for the ISO, and then you get the ASTMs, electrodeposit, zinc, aluminum, so on, okay? So this gives you the option that you can use, let's say, a steel bolt in the outside, for example, in a pole construction, steel construction, using one of these zinc coating, which is the typical color yellow you're gonna see, okay? Or you can see them kind of similar to the zinc type of metal color, or you can see them black. This is the typical, this is a coating, okay, that they add, okay? That gives you the option that you can use, as I said, steel bolts in environments that they could be, they could start corroding, okay, rusting, because the rust is gonna reduce the effectiveness of the bolt. You don't want that. It is really important that they don't rust. So you can use different options. You can also use paint, okay, but permanent coatings, let's say semi-permanent coatings, they're gonna be these ones, and they resist quite well in many of the environments, okay, not of the really hard ones like industrial with acids in the atmosphere, okay. When these ones they're not enough, or you're going to use them really high, let's say, uh, in the ocean, in water, salt water, things like that. Some of these coatings, by the way, they're really good, but if you really want to get better corrosion resistance, you can get stainless steel bolts. We're talking about them, remember, 3506-1. You're going to get different types. Some of them, like the austenitic ones, they're going to be really good against corrosion. You also can get aluminum or titanium if the weight is an important factor, okay? But there is something that you have to know also. When you're going to use aluminum, you're going to have in contact aluminum or steels, both stainless or regular steel. Just be careful that you don't get a galvanized or galvanic, sorry, corrosion. Okay, galvanic corrosion is because these ones, they are really far away in the chart, which means one is going to work as a cathode, the other one as an anode, and the anode one is going to basically sacrifice itself against in some specific environments. Okay, it's going to rust fast. Okay, so aluminum is going to be weaker in the corrosion against the steel. Okay, for that reason, I would say visit this website, for example. It's a good type. They're going to explain you a little bit what options do you have. Okay, it's not as bad as many people claim, but it could be a problem. Okay, you can protect, insulate, but in many environments you don't even really need that. Okay, but it's something you have to think about. Okay, when you're gonna put in contact steel and aluminum. Okay, especially if you use steel bolts, aluminum bolts, or use steel bolts against aluminum clamping parts. Okay. And this is so far the introduction. Okay, you get here also some bibliography. As you say, if you go, I'm gonna put the link below in the comments to here, and you're gonna be able to click in the introduction. You're gonna be able to download all these. Okay, this document where I explain all the standards. You can see different standards. Okay, check them in internet. You can find them, and you're gonna have all the information. Okay, and then you're gonna have some bibliography. Probably I have used other ones, like for example these design engineering handbooks and stuff that I don't have listed here. Probably I will make another list with more. And pretty much that's all. We will make a future video talking about the non-preloaded bolts, which is going to be the first part, calculating using equations, and also we'll make a video talking about this type of charts, which I haven't finished, with different stresses, thread areas, how to calculate that, and then the resistance, the load for both shear and tension. Okay.